Uh, all right, mic check. Y'all can hear me? All good?
Yes.
Okay. All right. Guys, we're finally back. Batman has exited the cave, so we're good to go now. So we're picking up where we left off on our CCNA journey. Where we left off at, right? Um, we were, we covered chapter 8, we covered chapter 9, right? But it's been a while, right? So I want to go ahead. I want to do a rush of covering for today and Sunday for covering what was covered in chapter 8 and chapter 9. Okay, so chapter 8, right? Chapter 8, the discussion was it's labeled um, implementing Ethernet virtual LANs, right? And so we spoke about what a LAN is, right? A LAN, right? A local area network. Okay, I know there's a lot of acronyms in tech. A local area network includes all devices or hosts that are in the same broadcast domain. Okay, they can communicate via layer 2 and layer 3. We are talking about switches, right? So we're going to say layer 2. Okay, all right. So again, that broadcast domain includes all devices that are connected, right? So what what considers what if we know what a local area network is? What is a virtual local area network, right? Basically, what a virtual local area network is, it's basically creating these broadcast domains on a switch via software. Okay, right? We can create broadcast domains via hardware. That'll just be a local area network. We can create, right, virtual local area networks via software. Okay, all right. And how we create that VLAN? Let's go ahead and go over it. You guys probably seen it before, but I want to go ahead and touch on it. And by the way, guys, you guys seen EVNG before, but I wanted to go ahead and not pre-create this lab. I wanted to do it from scratch. So we are looking for a switch. So let's go ahead and find a switch. Um, I do not like this update. The reason why I don't like this update, typically EVNG in the past would give you just what the iOSs that you have loaded up. Um, yeah, I don't really like the change. Let's name this switch dash. And we're probably going to need a couple more switches. So let's go ahead and let's make it 3, right? Because of course, like I said, chapter 9 is talking about spanning tree and rapid spanning tree, right? Very important chapter. I've been relearning a lot about that. So let's do that. All right. So first, let's go ahead and build our topology. Let's go ahead and architecture this. We're going to use switch 1, right? And what we want to do, right? Let's create a mock topology, right? And what we're going to do is going to say, okay, right? My Kivian and Yasin, that is my network engineers, and they want to go ahead and design a network for our engineering team, for our sales team, right? And our medical team. Okay. So what we're going to do, right? We're going to cover creating broadcast domains per department. Okay. So let's go ahead and do that, right? So let's do this. Let's go ahead and pull up our switch. Okay. Sorry if that's taking up the screen. Can you guys see it? Everything's good?
Yep.
We can see.
Okay. Awesome. Awesome. It's gonna take some time to boot up. Um, but let's cover what are the reasons why, you know, engineers, right, or engineers of the past chosen to create not just VLANs, but segment VLANs into smaller broadcast domains via department, right? One, right, to reduce CPU overhead on each device, right? Improving host performance by reducing the number of devices that receive each broadcast frame. What you guys learned in previous chapters, right, is that how a broadcast works, right, is with the 3 major roles of a switch, it is going to forward, right, a frame out of any interface, right, that is connected on the switch except for the interface that it received the frame on. Okay? Imagine if we had 7 switches, they're all in the same domain, and a broadcast message went out, right? It's going to mess up performance, right? right? And let's say, again, using our example, engineering, sales, and the medical department are all in the same VLAN. We don't want to do that, right? We want to lower the amount of hosts that broadcast frame can reach. Okay, so that's one reason why we go ahead and use broadcast domain. We use VLAN to go ahead and shrink the broadcast domain, right? Second, right, to reduce security risk by reducing the number of hosts that receives copies of frames that the switches flood. Okay, and again, this isn't just broadcast frames. This is multicast, and also this is unknown unicast frames, right? Which of course is another version of a broadcast frame, right? Um, of course, nowadays in the year of 2026, um, there can be outsider threats, right? External threats, but there can also be internal threats, internal threat actors within your environment. I believe that's called, and you guys can correct me if I get the term wrong, but you can have shadow IT. You can have insider threats that maybe can go ahead and get in your network and take down your environment, right? Just by having access. Okay. So, has you guys being those future network engineers and implementing network security, right? Us implementing VLANs limits, right? Reduces the number of hosts that can receive broadcast frames that may not be, that may just not be intended for everyone. Okay. Third, right? Why do we need broadcast domains? Why do we need those VLANs, right? To create more flexible designs that group users by departments or by groups that work together, right? Instead of just physical location, right? Let's say Antoine is an engineer for Microsoft, right? And um, and my you can quote me on this one. I know there's a big Microsoft building, right? One building that I know of, that's near Atlantic Station in Atlanta,
Yeah.
right? Okay,
Yeah.
right. And let's say, right, Antoine is their senior architect, network engineer, and there is 17 departments in that building, right? Thank you, Yasin. Excellent, excellent. Thank you so much. And I'll speak about that in a second. Thank you. Yasin, matter of fact, I'll give you a second to go ahead and talk about Shadow IT for what you found. But, right, based on that design, if there were 17 departments, right, if Antoine kept all departments, right, connected to switches, they were all just on VLAN 1. Can you imagine? Can you imagine if one host was trying to reach or connect to a new printer, right? How many broadcast frames would traverse that building? It'd be an insane amount. So, right, we want to go ahead and group it by department. We want to group it by host role, right? So we can make sure that we limit the amount of broadcast frames that traverse that broadcast domain. Okay. Um, Here's number five, right? Another reason why we go ahead and utilize VLANs, right? And this is one of my favorite reasons, is to solve problems more quickly, right? Because the failure domain for many problems is the same set of devices as those in the same broadcast domain, right? Let's use our previous example in the Microsoft building. If Antoine has printers, host, right? PCs, right? Let me not say host, PCs, servers, IoT devices, all in the same VLAN, and they say they cannot connect. How much harder is his troubleshooting methodology and his process going to be? It's going to be that much harder. He's probably going to take 3 times as more to try to find out the source of the issues, right? Why? We have to allocate, oh, okay, maybe, TCNs, right? Topology change notifications are being sent down, right, to each host, right? And let's say, right, I'm giving you guys a precursor, right, a little preview of the future. Let's say he's running RSTP, right? So every time a host goes into a forwarding state, right? It's not like STP, but it goes into a forwarding state. We're talking about RSTP. A TCN is set to the root switch and designated switches every time. So now the TCN, what happens when we receive a TCN, right? I don't know if you guys read forward or what have you. Whenever we receive a TCN, right, the switch's behavior is that it would go ahead and flush its MAC address table. What does that do? That makes the switch have to relearn all those MAC addresses again. Now, what happens to those hosts that had active connections, maybe to YouTube, maybe to a server that it needs to, a server that a host may need to interface with? We have now dropped that connection just because there's an issue on the network and all the devices in that 7 to 8 floor building, okay, are all on the same VLAN, right? It's meant for disaster, okay, right? And last but not least, reason number 6, right? Why we choose to implement VLANs, right? It's to reduce the workload for STP, right? Because it's a process within the CPU, right? So we have to keep that in mind, right? We have to reduce the workload for the STP process by limiting a VLAN to a single access switch. Okay? Any questions so far? I know I'm a little bit long-winded, call me an old man, but did any of that make sense?
Yes.
Yeah.
Okay. Okay, excellent. So let's start off. Let's go ahead and create a video. Let's go over that. All right. So first things first, we're going to get into our switch. Let's go ahead and make this a little bit less messy, right? We get into our switch, right? We just popped in. Y'all sit in Markivia, got this new switch into there, right? So we get into the switch. There's no authentication protocol set, right? There's no AAA set. So we can just go ahead and get in via console, right? We are now in user exec mode. Okay, right? We have access to a limited amount of commands, right? But we need to go ahead and we need to be able to configure the device, right? Globally, right? So we need to go ahead and head to privilege mode. Okay. And how do we do that? We go ahead and type the keyword enable. Okay. Let's go ahead and type that. That will take us to privilege exec mode, right? So now that we are in privilege exec mode, and of course you can tell the difference, we have this sign that tells us we're in user exec mode, and of course this tells us we're in privilege exec mode, right? Now that we're in privilege exec mode, what can we do? Now we can configure the device globally because now we have access to the configuration terminal. Okay, right? So let's go ahead and enter configuration mode, right? This is where we can make configuration to the devices, make change to the devices, change the time, et cetera, right? Let's do that, right? But the goal here is to create a virtual local area network, right? Create that broadcast domain via software. So let's do that. Let's do config, right? Terminal, right? Okay. So how do we go ahead and create that VLAN, right? You know me, I love the question mark. So let's go ahead and do the question mark. And of course, your book is going to show you how to do it. Of course, have those steps. But let's go ahead and go over how to do it. All right. Let's see if there's any commands that is related to VLANs. Okay. Uh-oh, something popped up, right? So we have VLAN command, right? And per the book, to create a VLAN, you would type the keyword VLAN, right? And we would go ahead and type a number 1 through 4094. Okay? All right. So I'll go ahead and say, to keep it simple, let's say VLAN 10. Okay? All right. And I stated, right, is that we're going to have 3 departments, right? We'll name VLAN 10 engineering, right? Now I want to create another VLAN, right? What I can do while still in VLAN sub-configuration mode, I can enter in, right, another VLAN. I can say VLAN 20. I don't have to exit the VLAN sub-configuration mode, right? And of course, I'll give it a name, right? Giving it a name is not mandatory, but it's highly recommended. Okay, so you can keep track, right? Your colleagues keep track of what's configured, what's the purpose, right? Because we have to go against theory of those 6 reasons that I just covered why we create VLANs in the first place. Okay, all right. last but not least, let's go ahead and create a third VLAN for the medical department. And let's say med, right? To go ahead and give it a name, we will type the keyword name and then, of course, give it a name. Okay, awesome, right? So with everything that we configure on a device, how do we check our work, right? Well, my friends, we go ahead and do that by show commands, right? There's a couple of commands that are related to just VLANs alone, right? We have access log, access map. You guys will see that in the future. We'll talk about that in the future. We got brief, we got ID, right? The main things here that you guys want to go ahead and take a, keep in your head for the exam is brief, ID, name, summary. Okay? Again, for the exam, brief, ID, name, summary. Now, why do you guys have to remember that, right? What is brief going to do? So what brief is going to do, right, is going to give us a shortened version, right, of our VLANs, the name of the VLAN, the status of it, and the ports associated with that VLAN. We'll talk about the ports associated with the VLANs later, right, and how to configure that, right? So we can see, right, we confirmed our work. We have the VLANs configured here, okay, right? Let's do another show command, right? Let's do a show VLAN ID, right? And what is that going to do, right? If I just do show VLAN ID 10, it's just going to show the information for VLAN 10, right? And the associated ports, right? Let's use let's use a VLAN that has associated ports. If I say show VLAN ID 1, it's only going to show me, right, information, right, from the show VLAN brief, but only for the VLAN that I indicated, which of course is VLAN 1. Okay? We went over that. Let's go ahead and let's do a show VLAN name, right? We can search by VLAN name, right? Show VLAN name, right? Whoops. There we go, right? So same thing, right? We can go ahead and search by name. Same way that we did it with the ID, we can search by name. So if you don't know, if you have thousands of VLANs, you say, hey, I know this is the engineering VLAN. Boom, right? You can take a look and see what ports are associated with it. Okay, let's do, and let's go ahead and clean up the terminal because I know it's a lot right now. Let's do a show VLAN summary. What does that show, right? This shows a couple of things, right? The number of existing VLANs. It shows us the number of existing VTP VLANs, right? Right? VTP stands for Virtual Trunking Protocol, right? Or VLAN Trunking Protocol, I apologize, right? And of course, the number of existing extended VLANs, right? So VLANs that are configured with a number that's beyond 1007. Okay, that's the extended, that starts the extended VLAN range. You guys will learn about that shortly. Okay. All right. So we created a VLAN. Okay. All right. So one of the things that you guys will need to do and need to understand for the exam is to understand 802.1q, right? So um understanding trunking protocols. Okay. Right. So how do we create a trunk protocol? What is a trunk? Right? When you're using VLANs in a network, right? Um, you can have multiple interconnected switches, right? They're connected, they're doing its job, but now we've implemented multiple broadcast domains, right? How do we know, right? How do we know one device is going to be able to communicate to um, another device within um, another device that may or may not be in the same broadcast domain? Let's test this out, right? So being being ignorant on purpose here, let's go ahead and start up another switch. Okay. All right, let's go ahead and get this started up. All right, that'll go ahead and take a while. Whoops. There we go. All right, that'll go ahead and take a while, right? But what we're gonna do, we're gonna go ahead and create this switch. We're gonna do the same thing, right? We're gonna go ahead and create VLANs. And we're going to see, right, if devices can go ahead and communicate with each other, being on the same VLAN in a different switch. Okay? So for our test, let's go ahead and do this. Let's go ahead and bring in some PCs, right? There we go. Let's bring, we need two. Okay? There we go. All right, we go ahead and bring two. Let's see the progress of switch 2 booting up. Okay. All right, switch 2 is booting up. And what we're going to do, we're going to go ahead and let's move PC4 right here. Let's just plug it into a port. So it's associated with gigabit 0/1 off of switch 2. Let's do the same thing here. Awesome. And let's save that. Excellent. Let's boot that up. Awesome. Let's boot that up. Excellent. And let's give it an IP address. Let's see, IP ADR. Let's do 10.10.10.4/24.10. Oops, 10.10.1. Whoops. Did I do this correctly? Maybe it once. It's been a while. 5. 10.10.10.1. Okay. There we go. Good old mistype from me. All right. So we gave it an IP address. Awesome. Right? Let's give PC5 an IP address. Excellent. All right. So IP 10.10.10.5. We'll put it in a /24. And you guys will learn about cited notations in the future. Excellent. Awesome. So they're both hanging off of gigabit 0/1, right? So let's go ahead. Let's make sure, right, we have the same VLANs configured on this switch, right? Oopsies, made a boo-boo. Okay. Go. Okay. And let's, hopefully this name lookup can be aborted. There we go. All right, so let's clean this up. All right. Oh, Jesus Christ. Well, I am typing terrible today. There we go. There we go. All right, enable. There we go. All right, let's clear that. All right, so let's do the same thing that we did. Let's create these VLANs. VLANs 10, that was engineering. VLAN 20, that was sales. And VLAN 30, that was med. Okay, awesome, right? So let's go ahead. And these are two engineers, right? We're still using that Microsoft building, right, that we spoke about earlier, right? Two engineers, right? One engineer may need to speak to another engineer on another PC, right? So let's go ahead and put them in the same VLAN on different switches. Let's do interface gigabit 0/1, right? And how do I go ahead and assign a port to a VLAN, right? I will use the keyword switch port access, right? Because I want it to be an access port. We'll talk about access and transport later in the future, right? We're going to do a switch port access VLAN and the VLAN I want to put it in, right? We say they're both engineers, so we're going to put them in VLAN 10. Okay. Let's save our work. Okay. Let's go into switch one and let's do the same thing. Okay. Awesome. All right. Let's go ahead and clear this out. Now, T interface gigabit 0/1. Okay. Switch port, access, VLAN 10. Okay. Save that. Excellent. Okay. So with that being said, let's go back to, okay, I'm not worried about that one. All right. So let's do this. Let's do our show command. Let's do show VLAN brief. Okay. All right. And so we see, right, off of switch 2, PC4 is assigned, right, to VLAN 10. The same, right? Let's go ahead and fix that. There we go. The same is for switch 1, right? We run that same command, right? So VLAN brief, right? Could have done a show VLAN ID, right? That's also in VLAN 10, right? So what happens if I pull PC4, okay, and I do PC5, and let's try to ping each other. Okay, okay. So why is it unreachable, right? So they're in the same VLAN, right? They're still in the same broadcast domain. So why is it unreachable, right? Here's the reason why, right? So within switches, right, um when we're talking about, passing traffic, right, via another data line or what have you, right, or another link, right? There's a difference between access ports, right, that's dedicated to one VLAN, and trunk ports. Trunk ports can carry multiple VLANs, right? Um, and trunk ports, of course, they connect via multiple switches, right? And they're able to carry multiple VLANs through that data link, right? By using a process called VLAN tagging. Okay, right? And what this does, right, is when, let's say, right, PC4, right, it's trying to send traffic to all hosts that are on the engineering VLAN, right? Now that there is a trunk configured, right, or there would be a trunk configured in the switch between switch 1 and switch 2, there will now be a VLAN identifier, right, that's included in the header whenever the frame is traversing the trunk. Okay, that is added, right? So that field is going to be added and that field is going to be inspected and looked at by switches. Okay, so once it sees that VLAN ID, 802.1q says that switch will only forward that traffic to, hosts or ports that are associated with that broadcast domain. Okay, so again, that sending switch, so switch 2, let me get my pencil. Switch 2 is going to add that header here from traffic from PC4. PC4 doesn't add headers, the switch does. Does that make sense?
Yes.
Okay. All right. So let's see that in action. All right. Let's go ahead. Let's go ahead and clear this out. And let's go ahead and configure a trunk. Okay. Okay. Let's lower this down and let's do switch one, right? Let's get in and let's do interface gigabit, right? Our interfaces, right, are linked between switch two and switch one to gigabit 0/0, right? So let's do that, right? And we're going to turn this into a trunk. So we're going to say switch port mode trunk, right? We could have done access on the previous ports. By default, okay, by default, right, straight out of the box, all ports on a switch are typically in access mode, okay, right? But if we wanted to go ahead and configure it to be, you know, unconditionally, an access port, we can do that, okay? All right, so let's go ahead and configure this as a trunk, all right? Okay, um, and I'm glad this popped up. So this error right here, right? This is only done, right, on older switches or older code, right, that still uses you know, a certain trunk encapsulation command that says, hey, are you using ISL or 802.1q, right? So we need to put in the command. You guys don't need to remember this for the exam. I need to put in this command just for this lab that says, hey, don't worry about the encapsulation, right? So let's do switch port. What is that? .1q. No. Push port trunk. Encapsulation. There we go. And we'll do .1q, right? Excellent. Now I should be able to set it as a trunk. There we go. Okay. All right. Let's go ahead and set the other switch as a trunk, and then we'll come back and we'll talk a little bit about a couple of things. Of course, we're getting errors about VLAN mismatch. We'll go ahead and take care of that once we configure the trunk, okay? So let's do interface gigabit 0/0. Okay. We're going to do the same thing, right? Switch port trunk, encapsulation, we're going to tell it the encapsulation mode, right? .1q. And now we're going to set the mode, switch port mode trunk, right? No other configurations outside of that. All right. So let's go back to switch one and let's do a couple of verifications, right? There's a verification command that we can use, right, to go ahead and verify a couple of things, right? What interfaces are participating in the trunk, right? What VLANs are traversing the trunk, right? And so on, right? So let's go ahead and do that. As you guys can see, of course, there's um, still errors here, but don't worry about that. Sometimes that is within software. Um, and of course, typically when you guys are emulating something, right? If you guys have your own home lab, sometimes the emulator does get buggy. So simple reboot. I'm not going to reboot now. I know we're getting to the close to the end of the session, but we'll go ahead and I'll reboot it before Sunday so we can go ahead and not have this issue. But let's do some verification, okay? So let's do show trunks, show interface trunks. I apologize. All right. Uh-oh. Show. There we go. Uh-oh. Did I not? Let's take a look at that one. Um, let's take a look away. I can take it. Let's take a look at our configuration to see what's going on. There we go. Okay. That is correct. Let's do. Let's be safe. 0/0. Let's do the same thing on switch two. as it is, older code. There we go. Switchport truck, VLAN 1. Yeah, there we go. Okay. So now we have that configured. Let's go ahead. All right. So now we have that configured. Let's go ahead. Still showing us the mismatch. Let's take a look. Show interfaces, gigabit 0/0. Let's take a look at that. Okay. All right. You see a couple of things here, right? Interface is up. Line protocol is up. Let's do this. All right. Let's do another one. So switch port. So interface, switch port. All right. So interface, gigabit 0/0. And we should have, there we go. Awesome. Okay. So, right, show interface is gigabit, right? And of course, the interface name, we get to see a couple of things, right? We get to verify it is running as a trunk, right? I'm not sure why this says static access. I'll get you guys the answer in the future. Again, it could be old code, so don't worry about that, right? We do know, right? It's configured for .1Q, so 802.1Q, right? We do have natively set, right? Right. And we also know the native VLAN is VLAN 1. Okay. For right now, this is all that you have to check and make sure, right? Here's another thing that we can also see at the bottom of this, right? To verify that the trunk is working, right? All VLANs are enabled, right? On this interface, far as traversing, right? Pruning these VLANs, right? And we see all VLANs are allowed, right? So, of course, let's see if the show interface trunk is working now. It may be buggy. Yeah, I think it's still buggy. Hold on 1 second. Let's do that. Okay. Right. Yep. Okay. So yeah, so it's being buggy, even though we have configured the trunk. So I have an example that I can show you guys. We'll reboot that in the future. Let's go ahead and zoom in. Right. So whenever you do, right, the show interfaces trunk command, here's where you can go ahead and confirm, right? You can confirm the port, right, that's participating in the trunk, right? You can see the mode, right? You can see the encapsulation, right? And you can see the trunking, right? The status, right? The trunking. And of course, you can see the native VLAN, right? That it's operating in. Okay. All right. Any questions so far?
No.
No, none for me. This is a
Okay.
good lab. Yeah. I was actually
Okay.
looking at VTP today, actually,
Mm-hmm.
on a core switch at
Okay.
work. So yeah, this is actually good.
Okay. And you know what? Maybe I forgot a configuration. Hold on 1 second. Let me just let me check something on why that's not popping up. Switchboard mode. Okay. Now we're good. Yeah, I'll look in to see why that's not working. Um, yeah, and I'll follow back up with you guys on Sunday. But we'll stop here. I know it's getting to the 30-minute mark. I don't want to go too long. And we'll continue on chapter 8, talking about um, VLAN concepts, forwarding data between VLANs, VLAN and VLAN configuration and more VLAN trunking configuration because I do want to get this working for you guys. And guys, just remember to bring questions or what have you, right? So again, we'll continue on to chapter 8 on Sunday. Next Thursday, we'll go ahead and we'll move to chapter 9 for that review, and then we'll go from there.
Already sounds good. Thank you, David. This
All
is
right,
good.